Welcome to 6-1 Law of Sines, Day 2. We are going to continue going deeper into this Law of Sines, oblique triangles, side-side angle case. Remember, in the last video, we're always going to check for a possible second triangle. And in that example 3, we found out there was only one solution. There was no second triangle. So in this video, we're going to see the case where there's no triangle at all. And then the final case where there are two distinct triangles. So let's go. Here we go. I got a triangle set up here. I got some given info. Side A is 15. Side B is 25. Side A is angle A is 85 degrees. 85 degrees. And I always like drawing the picture because it always shows you your first starting fraction. We have a side, and we have the angle across from the side. So that's our first setup, 15 over to sine of 85 degrees. You can make sure your calculator's in degree mode. And that's going to be exactly equal to, the other side they gave us is 25, and the angle across from that is the one we're going to find first. We have to. So that's going to be 25 over to sine of b. Oops, 25 over to sine of angle b. And if we cross multiply and divide, we would start by cross multiplying here. 25 times the sine of 85 degrees. And that's going to equal the other diagonal, but we're going to divide by 15 to get the sine of b alone. So that over 15 is equal to the sine of angle b. Now this, if I were to do all this stuff on the left, let me block it off here in black ink. If you punch that into your calculator, you're going to get about 1.66 and then some other numbers. But what's going to happen when you try to sine inverse that? Because remember, to get angle B alone, we're going to sine inverse. Well, that number is bigger than 1 or less than -1, so you are going to get an error message. Error. Not only there's not even one solution, there are no solutions in this case. And what's happening is the sides will not connect. So here, of course, my triangle is not drawn to scale. Angle A is 85 degrees. It's almost a right angle. A. Side A, or side B is 25 feet. So this side here is nice and long. But side A is only 15. So if I put side A like up here, it's only 15 feet long. It cannot come down and connect. So this would be just up here swinging back and forth like it's on a hinge. There's no way for all three sides to connect. So it is a no solution case. The calculator said error. There is no triangle. All right, the biggie. Here is where we're going to find two possible triangles. And if I remember, this is the last example in this video. Yeah, we'll do a couple practice problems. This is the last example, though. So here, because I know we're going to have two solutions, I've given you two triangles. And we're going to mark the given info on both. Side A is 12. Side B is 31. And angle A is 20.5. 20.5. That will be true on both triangles, if two triangles exist. 20.5. Okay, we're going to start, of course, on the triangle on the left, and let's set up our law of sines. We have 12, and we have the angle across. So that's going to be 12 over to sine of 20.5. And that is equal to, the other side we have is 31, and that's across from unknown angle B. So 31 over to sine of angle B. So, of course, we're going to cross multiply and divide. After you do enough of these, you don't even really have to write out the steps. Right from here, you could take your calculator and multiply 20.5, hit the sine key, times 31 equals, and that will be that value. Now you're going to divide it by 12, and that will give you a decimal, and then you'll sine inverse. So in this case, angle B is about 64.8. 64.8. Now notice again, they forced us to go for angle B. There was no other alternative. So this first angle that we found was 64.8. Now we're going to check for angle B in the other triangle. If there is another triangle, that angle B is going to be 180 minus 64.8. And 180 minus 64.8 is 115.2. So over here in the other triangle, angle B is 115.2. And notice both of these triangles, there is enough degrees left over to find angle C. So let me get this out of here. And that might be, let's go for that next. That's easy stuff to find. Let's find angle C in both triangles. So here on the left, angle C is going to be 180 minus 20.5 minus 64.8. And in the other triangle, angle C is going to be 180 minus 115.2 minus 20.5. So in the first triangle, our angle C is 94.7 degrees. And in our second triangle, angle C would now be 44.3. 44.3. Remember, a triangle can only have 180, and here we have two triangles with the same given info, but they have different angle B's, and that means they're going to have different angle C's, and that means side C is going to be a little different for each of them. So our triangles are almost solved. We just need side C for each triangle. So I'm going to come back over to the first triangle, side C over here. Remember to use the given info as much as you can. So I'm going to use the 12 over to sine of 20.5. And that's going to be equal to C over the sine of 94.7. And let's set up the other one. I'll switch to blue ink. That's going to be the same starting fraction, the 12 over the sine of 20.5. And that's going to be equal to over here, we're going to have C over the sine of 115.2. 115.2, there we go. So over there on the left, in red, if we cross multiply, 94.7, take the sine, times 12 equals, divide by 20.5 sine equals. Over here, side C is about 34.2. So I'm going to put that on the picture here, 34.2. And over in the blue, if we multiply 12 times the sine of 115, divide that by the sine of 20.5, this angle, or side C, is about 23.9. And that makes sense. Bigger angle C means a bigger side. Smaller angle C means we're going to have a smaller side. And in each of the triangles, the biggest angle is across from the biggest side, and the smallest side is across from the smallest angle. So in this case, we do have two different solutions to the same given information. Again, this is why there's not a side-side angle theorem in geometry. And here's what's going on graphically. Again, my triangles here are equilateral, equiangular, but here's a more specific one where the angles and sides are proportional. So here's our first one. Side A is 12. Yeah, there we go. And here's what's happening on the other one. So imagine this side C that I'm hitting in red ink. Imagine angle C is a hinge, and this red side is going to swing over until it hits here. And this is the other side C. That's what we see here in this picture on the right. So between these two triangles, the stuff that was given is identical. This side and a couple angles are going to be different because we have sort of that hinge where that side A swings over. And we have two possible solutions. All right. In the checkpoint, the practice problems, you'll have one of each. You'll have a no solution, and you'll have a two solution. So pause the video, take those for a test drive, and then fire it back up and see if you got the right answers. So, on this one, they spoil the surprise. Show there is no triangle. So we go into this knowing there's not going to be a solution, but that doesn't mean we can't have a little fun doing math along the way. Side A is 4. 4. Side B is 14. And angle A is given as 60 degrees. So we've got a side and the angle across. So that's our setup, 4 over to sine of 60. And that's going to exactly equal 14 over to sine of B. 14 over to sine of angle B. If we punch that in our calculator, we're going to try to take the sine inverse of 3.031. Of course, we can only put numbers in there between 1 and -1, so we are going to get an error message. There's no way for the sides to connect to complete the triangle. There is no triangle. Okay, here's our other practice problem. Whoa, there we go. I'm going to move this up here. Now remember, the given info is true on both, so I'm going to use black ink. A is 4.5, 4.5. Side B is 5 feet, 5 feet. Angle A is 58 degrees. So set up and solve for angle B. As soon as you find the first angle B, subtract it from 180 to find the other angle B. And from there you can find the missing angle C's and the missing side C's. So pause the video, try it out, and fire it back up to see if you got them right. All right, on the left side, we've got 4.5, and that's going to be over to sine of 58. And that is equal to 5 divided by the sine of angle B. So there's our setup. And in this case, when we cross multiply and sine inverse, you should get angle B is about 70.4. 70.4. So I'm going to write that up here in red ink, 70.4. That's the first angle that we solved, so we're going to check for our second triangle. 180 minus 70.4 is 109.6. So 109.6. There we go. And when we solve each triangle for the missing angle C, there is going to be enough degrees left over to put an angle down there. I'll switch to blue ink. So here on this one with the 70.4 angle B, this angle C is going to be 51.6. And in our other triangle, angle B is bigger, so that means angle C is going to be smaller. Over here, there's only 12.4 degrees left for angle C. Okay, so we've got two triangles. They both have 180 degrees. Everything looks good. We're just going to find the missing side C. So here on the left, let's use the given info again. So that's going to be 4.5 over to sine of 58. Sine 58. And that is going to be equal to C over to sine of 51.6. 51.6. And if you solve that one correctly, you're going to get C is approximately 4.2. So this side C is about 4.2. And if we come over to the other triangle, we're going to have 4.5 over to sine of 58 is equal to C over to sine of 12.4. And if the calculator button pushing goes well, you should get approximately 1.1 for that missing side C. 1.1. Alrighty, I think that is the end of the video. When I see you in class next, we will do some odd problems here. WebAssign will be the even stuff. Alright, and I'll see you in class or in the next video.